So now what we want to do is we want to look at row number 1, row number 5, and then row number 7 and 8. Okay? Those are the critical rows. Okay? Any row in which all the premises are valid or true is a critical row. What we have to do is we have to determine if this is a valid or invalid argument form by checking the conclusion now. Okay? So I'm going to have P implies R. Okay? So I have P which is true, I have R which is true. True implies true is a true. So far so good. I have false implies true. Well, that's true. Anytime it starts with a false. And then, guys, the last two start with false as well. So these are true. So, because the conclusion is true in all the critical rows, we're done. This is a valid argument form. In fact, some of you guys might actually recognize this as one of the 8 of the basic rules of inference. So, look at that sheet that we just used about 20 minutes ago. Which rule of inference did we actually just verify? The transitivity rule. Okay? So this is a way that if you guys ever wanted to verify any of these rules, you just use a truth table. Okay? So basically we have to answer the question, and this is valid by table. Does this make sense, guys? It's not difficult, okay? We've been doing truth tables a lot for the past couple of days, so I'm hoping you guys are pretty good with that. All right, so what I'd like for you guys to do, take about 5 minutes, see if you guys can see if letter B works, okay? Or maybe not work, okay? And then we'll go through the answer together.
What was the last blank on the...
Oh, I'm sorry, sir. Back up here.
The
last fill in the blank.
Yeah,
Valid. I'm sorry, sir.
Thank you.
Yeah, if I'm ever moving too fast, yell at me, okay? Because you guys are paying for the course, not me. So I just want to make sure I'm not cheating you on your education. When I worked it through, guys, I only got that 3 of the rows actually mattered in the entire problem, okay? So, and that's definitely helpful, because think about, like, I mean, you're eliminating 62.5% of your work by getting rid of those rows, okay? So, when I did this, okay, be careful with the implies, okay? That's the only one that gets messy. But my first row, my third row, and my fifth row are all critical. And if I look at the critical rows, it looks like that indeed the R is going to be true. In fact, you didn't, I made an extra R column. You didn't have to make the R column, right? I bet you most of you guys just looked at this and were like, oh, that's R, duh, I don't need it again. Right. So guys, this does indeed work out to be one of the valid argument forms. Okay? So, by the way, and some of you guys might have seen this before, but does anybody know what structure this is? It's not on your worksheet, but this is it's a valid argument form. I don't know, and I know a couple of you guys might have taken logic before, but if not, this is actually called division into cases. Okay? So basically what this says is that either P or Q is true, P implies R, Q implies R, so that means they both imply that some conclusion is valid. That means that the conclusion must be true. Okay? Later in the course, we're actually going to use division into cases as a methodology for proof, okay? Because think about, like, if I wanted to prove like an integer statement. Integers are either odd, right? Or they're positive, negative, or zero. Those are division into cases, okay? We're going to look at different types of cases later in the course, okay? Regardless, okay? Everybody okay doing this? Any questions, guys? Okay, Andre and then Art.
What are the different cases that this would be invalid? Like what
Gotcha.
makes it invalid?
So let's say for some reason, okay, that's a good question. Let's say for some reason, and I know this isn't right, but let's say this R, which is the conclusion, is false, right here, in a critical row. That would make the entire argument form false.
Okay, is that the only way that it could be?
Correct, that is the only way, as long as one. I mean, it could be several, okay? But as long as you get at least one of the conclusions in the critical row false, it means the whole thing's false. Okay, does that make sense, sir? They all have to be true, otherwise no good. Okay, good question, thank you, sir. Okay, sir, you had a question. Same question, you just took it from your mind. That's kind of creepy, man. Don't do that again. All right, other questions I can answer. Sir?
I'm just saying, in that case, if we go through and we find the first one false, just stop.
Yep, you got it. That's exactly right. Yeah, don't waste time. I mean, if you guys know it's going to be false, just go with it. Nice, good point. Okay. Sir?
So that true at the second seventh row doesn't mean anything?
That's correct.
It's
Because
not critical. And
correct. Right. Because it's not critical, don't care. Okay? And that's why you guys just ignore non-critical rows. Just waste your time. Excellent, sir. Very nice guys, sir. Good stuff. All right. Other questions, comments? Okay. All right, guys. Let's just take a look at another pair of easy problems, and then we're going to have to suffer through some difficult ones at the end. Okay? These are ones if we actually have it formulated in some sort of sentence. Okay? What we want to do is we want to try to build one of the forms that's at the bottom of your guys' worksheet. Okay? And when I say the worksheet, I mean the basic rules of inference. Okay? So what we're trying to do is we're trying to rewrite the statement or the sentences so that it looks hopefully like one of those, and if it doesn't, it's invalid. Okay? So let's take a look at a couple examples of this as to how we can do this. Okay? One of the first things we ever did in this class was I gave you a sentence, you wrote it in symbolics. Okay? That's what we're going to do right now again. All right. The question is, if Bob answered this correctly, he answered invalid. Bob answered invalid. Therefore, Bob answered this correctly. All right? Let's try to write this argument form symbolically. Okay? I need two statements. What are the two statements that comprise, or what's one of them? Sir?
If Bob answered this correctly.
Bob answered this correctly. Nice. And then you guys just chop off the if because it's not conditional. Nice. So, one of them is Bob answered this correctly. And then, what's the other statement that comprises this argument form? So, sir?
he answered invalid.
He did answer invalid. Okay? So, he answered invalid. Okay? So, just like we did at the beginning of class on Monday, we define statements, okay, using variables, okay? Everybody can do that, okay? All right, let's see if we can write this in one of the forms, okay? So, if Bob answered this correctly, he answered invalid. How would I write that statement symbolically using our definitions?
P implies Q.
P implies Q, perfect, okay? So, if I want to write this symbolically, P implies Q. The next line, Bob answered invalid. How do we write that symbolically?
Q.
Q, right? I mean, it's right there. He answered invalid, so it's Q. Therefore, Bob answered this correctly, which is P. Okay. So, that is the argument form of that argument form symbolically. Okay, does that make sense, guys? That's easy to do, right? We can all do that. What we're going to do is we're going to go back to the basic rules of inference, and we're going to see if it matches. Okay? So, I look at modus ponens. P implies Q, P therefore Q. I have P implies Q, Q therefore P. So it's not modus ponens, right guys? Because those are flipped. It can't be modus tollens because it has nots in there. And then the rest of them don't even have implies except for transitivity, which it doesn't. Okay? What does that mean then, guys? It means it's not valid. Okay? If it is not on there, it is not valid. Okay? So you would say that this is not valid. This is actually a specific type of error, and maybe some of you guys have seen this before. What type of error is this specifically exhibiting? It starts with a C.
Circular.
Not circular, good try, good try. Converse error, okay? Remember we talked about the converse, where you flip the P and the Q? If this was P then Q, not Q then P, we'd be good. But unfortunately, because we flipped those, this is indeed a converse error. We said that only the contrapositive is logically equivalent. Isn't modus tollens the contrapositive? If you look at that, you're just flipping the order of those, okay? So, does that make sense, guys, as to how to do this? It's not meant to be difficult, okay? This is a really easy problem for everybody to do, okay? Let's take a look at a secondary example, okay? If I go to sleep early, then I will wake up early. If I wake up early, then I will be energetic all day. If I go to sleep early, then I will be energetic all day, okay? I believe that we have 3 statements in there. Okay, sir, please.
Sorry, I just have a question about
Sure.
this problem.
Yeah.
So I don't understand what was logically wrong with the statement then.
Oh, okay. The order was incorrect in which it was presented, okay? So if you look at the modus ponens, okay, this is valid. It says that antecedent leads to conclusion. This is the conclusion. This is actually begging the conclusion, or I think maybe you said circular, which is almost, or somebody did, or something like that, which is almost the case, to where what you're doing is you're putting the conclusion before the antecedent, okay? So logically, that's what's happening. You're begging the conclusion, okay? It's almost like when you guys are doing homework sometimes, and you're like, screw this, I'm just going to go to the back of the book and write the answer. That's exactly what this is, okay? It's just skipping right to the answer, okay? So it's a good question. Thank you, sir. Okay. Other questions, guys, before we move on to the next one? Okay. So, like we said, I believe that the next one has 3 statements in it, okay? So I think one of them is going to be, I go to sleep early. So let's go ahead and knock this one out. Okay, so let's say P equals I go to sleep early. Q is going to be I will wake up early. And then R is going to be I will be energetic all day. With enough Red Bull, that's certainly valid. Or Red Bull and Jaeger. Which is basically a speedball whenever you do a Jaeger bomb. Because one of them is a stimulant, the other one's a depressant, so. Anyway, regardless. So things you really learn in this class, right? Okay. Sir?
So when it's necessary, we have to actually say what they are.
Yes, sir. Okay, unfortunately you have to define them. And the reason being is because it's linking to computer science, and you guys know when you're building a program, first thing you have to do is define your variables. Okay? All right, so let me ask somebody, Okay, can you guys go through and just tell me what the argument form is going to look like if I were to translate this sentence using the symbols? So what's the first sentence look like? So start.
P implies Q.
P implies Q. So the second one?
Q implies R.
P implies Q, Q implies R, and therefore, what does that mean, guys?
P implies R.
We may have seen that earlier today, okay? Guys, which of the 8 of the basic rules of inference does that fit, Don? The transitivity. And guys, how do we know transitivity is valid? Because we freaking proved it, okay? So there's no way that this could be wrong, okay? Unless I just pulled some algebra magic, hocus pocus, and made you think it was right when it's really not, okay? But this is valid by transitivity. Alright. So I always tell people, if you can write it symbolically, it's probably a lot easier to be able to determine validity versus invalidity. Okay? The last one, very, very easy. Okay? Homer works at power plant, so P is Homer works at a power plant. And then Q is he sleeps on the job, or Homer sleeps on the job.